So now let's figure out what happens if we start heating up our cold worked metal alloys. Now, heat treating cold worked metals will bring about changes in the structure and properties. Sadly, it's going to completely nullify our cold work. But sometimes we want this. I mean, we won't nullify it all the way. We'll cold work a material and then we'll heat it up. This is a term called annealing. Now, it will decrease the tensile strength and increase our percent elongation. And sometimes we can get to a point where we're stronger than we were beforehand, but we're also more ductile than we were just a moment ago when we had cold worked only. And it looks something like this. You can see, as we begin to increase the annealing temperature, while our tensile strength begins to drop, and our ductility begins to increase. And if we keep on heating it up, we'll eventually get to this point where all of our cold work is gone. Our tensile strength and ductility will level off. And there are 3 annealing stages. The first stage is recovery, the second recrystallization, and the third grain growth. So what do we mean by this? Well, during recovery, there's a reduction in dislocation density, or an annihilation of dislocations. So you can see that doesn't do quite as much in changing our tensile strength or our ductility. Now, how does this happen? Well, it might be something like this. We have an extra half plane of atoms in both sections. However, they're able to move because it's got some heat and it's able to move more easily. And what happens is they then move together, and suddenly the half plane of atoms becomes a whole plane of atoms. And it's no longer a dislocation. They annihilate each other. So that's one scenario. Scenario 2 might be that there's a dislocation that is blocked. Can't move to the right because there's another obstacle in its way, and they're repelling each other. Well, if that is able to then diffuse upward into a different section, well, it can now move, and hopefully it will eventually find a dislocation of opposite orientation, and they will annihilate each other. They'll annihilate each other. Now, recrystallization, it's when we have big, large, stretched grains, and then we go from there to very, very small grains. Our big grains turn into small grains. These grains we have, because of random dislocation motion, it becomes smaller. And they will consume and replace our old cold work grains. And if we look before, that's when we begin to see a significant drop in tensile strength and a great increase in our ductility. And eventually, all of those grains will have been completely consumed or replaced. Now, if we continue to leave it there, then the grains will grow. So if we increase it even further, well, we're going to grow. So where does that recrystallization temperature happen? Well, it varies from metal to metal, but it is somewhere between a third of the melting temperature and about 60% of the melting temperature. Somewhere in there. And that's the temperature at which recrystallization will reach completion in 1 hour. And it does depend on different things. It depends on the percent cold work, as well as the purity of metal. As the metal purity increases, the recrystallization temperature decreases. As the percent cold work increases, the recrystallization temperature decreases. If you're wondering why that is, well, one of the ways that recrystallization happens is we have these, large grains, and we have all this ability to move. And as we have cold worked these grains and compressed them and squished them, well, they're more easily going to break apart. Okay? If I have a box like this, I'm trying to cut a line through that box. Well, it takes quite a bit of time. Or if I'm saying that just the edges are going to be breaking off first, well, there's less area right here than a longer, thinner box. I mean, if temperature is coming from the outside, diffusing inward, this is a lot more surface area to then be cut off of by the grains. Or if those grains are having to cut all the way through and break off a section, it's a lot easier when there's one section that's a lot shorter than another. So that's just a physical reason for why it might be percent cold work could be causing the decrease in the recrystallization temperature. Okay, so last two things we're going to talk about, I think, yes, is hot working and cold working. So cold working is when you do deformation below the recrystallization temperature, and hot working is when you do the deformation above the recrystallization temperature. And you can typically do a lot more hot working than you can cold work. You can apply a lot more stress to something while it's hot and warm and able to move, is more flexible. Just think about like working out after you've stretched. You always want to stretch before you do something strenuous because you don't want to pull a muscle. Well, cold working is like when you work out cold, you can do less. Hot working, you can do more because you're already warm. So that's it for this time. Thank you for listening. I'll see you all later. Bye-bye.